Good morning everyone. Today we will study numerical integration using interpolation formula. In last class we have seen numerical differentiation using interpolation formula. So here we can find integration like I is equal to f of x dx in a given interval. Okay. So, in order to study numerical integration, we will see first method. It is Newton's Cote's quadrature formula. First is Newton's Cote's quadrature formula. Okay, so first we derive this Newton's Cote's formula, and then we'll find various quadrature formula. In order to find the integration, I is equal to a to b f of x dx. Okay, so we will find integration f of x in the given limit. Okay, using numerical interpolations, different this quadrature formula. Okay, so let's suppose we have like this, okay, and initial point is x naught, x and y, and this is x n. Okay, so let I is equal to integration a to b f of x dx, where f of x takes the values y0, y1, y2 up to yn for x is equal to x0, x1, x2 up to xn. Okay, so f of x is equal to y0, y1 for x is equal to x0, x1, x2, so up to xn. Okay, so let us divide the interval AB. So this is A to B. Okay, so we have to find the integration of this curve. So we are dividing this curve AB into sub-intervals, n sub-intervals with width h. So this is h. So this will be x0 plus h. So this will be y0. This will be y1. Next, this will be x0 plus 2h. Then this is y0. This is x0 plus n minus 1 into h, and this is x0 n into h. This is y of n, this is y of n minus 1. Okay, so the curve is divided into n sub intervals with width h, and x0 is equal to a. So x0 will be equal to a, x1 will be equal to x0 plus h, x2 is equal to x0 plus 2h, that is equal to xn is equal to x0 plus n into h. Okay, so which is equal to, so this is our starting point A and this is the end point B. So we have divided this curve into n sub intervals starting from x0, x0 plus h, and the width of the interval is h. Okay, so these are the values. So then I is equal to, So this can be replaced as, so A is x naught here, so x naught, and B is x plus nh, x naught plus nh, okay, f of x dx, okay. So let x is equal to x naught plus r into h, where dx is equal to 0, this will be h into dr. Okay, so we are substituting x is equal to x naught plus r into h, and differentiation of this with respect to x, this will be dx is equal to h into dr. Okay, so this will become integration. So x is replaced by f of x naught plus r into h, and dx will be h into dr. Okay, so what will be the limit? So when x is equal to x naught, when x is equal to x naught, for limits, so this will be x naught is equal to x naught plus r into h. So r will be equal to 0. So r will be equal to 0. So this is with respect to r, and when x is equal to x naught plus nh, x is equal to x naught plus n into h. So x naught plus n into h is equal to x naught plus r into h. X naught cancel out, h's cancel, r is equal to n. So this will be from 0 to n. Okay, so limit will change, it will be from 0 to n. Okay, so from forward difference interpolation formula, we can write this as is equal to h is taken outward. Okay, so this is integration 0 to n. So this can be written as y naught plus r into delta y naught plus r minus 1 divided by factorial 2 delta square y naught plus r minus 1 r minus 2 factorial 3 delta q y naught plus r minus 1 r minus 2 r minus 3 divided by factorial 4 10 to the power 4 y. So we have seen this into dr. Okay, so this will be this is the formula using Newton's interpolation formula. Okay, so this will be equal to h into 0 to n y naught plus r delta y naught plus this will become r square minus r by factorial 2 plus square y naught plus this is r square, so this will be r2 minus 3r square plus 2r divided by factorial 3 is 6 into del cube y naught plus 2. Okay, so into, okay, you can do it yourself. So now we will integrate it with respect to dr. So this is by Newton's forward interpolation formula. So now we will integrate this. Okay, so this will be equal to, so from x naught to x naught plus n into h f of x dx will be equal to h So integration, this will be y naught into dr. So this will be integration dr. So this will be r. So this will be y naught into r from 0 to n, plus this will be r square by 2 from 0 to n del y naught, plus this is the integration of r square is, so this is factorial is 1 upon 2, so r cube by 3 minus integration of r is r square by 2 del square y naught by 2 plus from 0 to n differentiation of integration of r cube is r to the power 4 by 4 minus 3r cube by 3 plus 2r square by 2 del to the power 4 y naught by 6. Okay, so this will be from 0 to n. So we have integrated this equation with respect to a. Okay, so now substitute n in place of r. So this will be n y naught. This will be n square by 2 del y naught. This will be n cube by 3 minus n square by 2 del square y naught by 2 plus n to the power 4 minus r cube plus this will cancel out r square del to the power 4 y naught by 6. Okay, so this will be n. Okay, so taking n common, so this can be written as n into h. This will be y naught. This will be n by 2 delta y naught. This is 2. Taking n common, one n is taken out. So there will be only one plus n. So 2n minus 3 divided by 6 into 12 del square y naught, and taking n common. Okay, so this will be n. So this is n square minus minus 4n plus 4n. 4. Okay, so this is, if you take n square common, so this will be n square minus 4n plus 4. So this is nothing, this is n minus 2 whole square. N minus 2 whole square. Okay, and divided by 4, it is 20. Okay, so you can write like this, and further terms. Plus, you can write further n to the power 4 minus 5 3n square into 5 2 plus 11 n square by 3 minus 3n del to the power 4 y naught factorial. Okay, so this is the value of I, integration I. Okay, so this is known as Newton-Cotes quadrature formula. So let's suppose this equation as equation number 1. Okay, so we will derive some more quadrature formula using this equation. So this is known as Newton-Cotes quadrature so this is the general formula, and we will use important quadrature formula by taking n is equal to 1, 2, 3, 4, and so on. Okay, so this is the basic formula. Okay, Newton Cotes quadrature formula, and we will put n is equal to 1, 2, 3, 4, 5, and so on, and we will introduce some more important quadrature formula. Okay, so this is the basic formula. Okay, so first is trapezoidal rule. Okay. So we will derive the first rule, that is trapezoidal rule. So putting n is equal to 1. So putting n is equal to 1 in this equation. Okay. So the curve will be like this. So there is 2 point. This is the y0 and this. So we are taking n is equal to 1. Okay. So this is x0 and this is x1. So area of this will become a trapezoidal. Okay. So this is known as trapezoidal rule. Okay. And taking the curve through the straight line, this is y0. This is x0, y0, and this is x1. Okay, so curve will pass through this straight line, and this is y. Okay, this is x, this is y. Okay, so this curve will be obtained. So it's a straight line. The polynomial of the first order, or the difference of higher order, then first become 0. Okay. So this is a straight line. So higher order will be 0 here. Okay. So this is the polynomial of first order. Polynomial of first order. So the difference of higher order than first becomes 0. Okay, so higher order other than first difference, this will become 0 since it is a polynomial of first order. Okay. Polynomial of first order. Okay, so we will get only this. So this term will be become 0. So this is integration x0 plus n into h f of x dx. Okay, so here we are putting n is equal to 1, so this will become x0 plus h. Okay, so this is x and this is x0 plus h. x1 is what? x0 plus h. Okay, so x0 plus n is 1. Here n is 1, so this will be h. So f of x dx is equal to 1 into h. Okay. Then y0 plus n is 1 upon 2. y0 plus del y0 by. Okay, and higher order will become 0. Okay, so this will be written as, so del y0 is nothing y0 minus y0 divided by 2. So this is first difference, first forward difference. So del y0 is y1 minus y0. Okay, this is y0 minus y0 half. So this will be half by y naught plus y. Okay, so similarly we can find next x naught plus h for next interval. So this is x naught plus 2h. Okay, so this is implemented by h. So f of x dx. So this, and then we will add. Okay. So this is x2. So this is x2, x3, and up to xn. Okay, this will be value of y2, y3. Okay. So we will get h by 2. So this will become y1 plus y2. Okay. Then third, from this is x0 from x1, x1 to x2, then x0 plus h, 2h plus x0, 3h, f of x dx will be equal to h by 2, y2 plus y. Okay. And similarly, up to n integrals, x naught plus n minus 1 into h, x naught plus n into h dx will be equal to half y n minus 1 plus y of. Okay. So now you can find the adding these n integrals. These n integrals we get from x naught to x naught plus n into h f of x df of x. Okay, so h by 2 is common, so h by 2 is taken common. Okay, so here what you see it is y naught, y1, y1. Okay, and y2, y2, then y3, y3, and so on. Okay, so and here is yn. Okay, so this will be y naught plus yn. There is no second y naught and yn, and this is y1 plus y1, so this will be 2y1. Then y2 plus y2, this will be 2y2 plus y3 up to yn minus 1. Okay, so this is trapezoidal rule. So this is which is derived from Newton force quadrature. Okay. Next, we will divide next formula, that is putting n is equal to 2. Okay. So next formula is Simpson's 1/3 rule. Okay. Second. So next is Simpson's 1/3 rule. So putting n is equal to in equation 1. Okay. So here we will put n is equal to 2 and we will find Newton's 1/3, Simpson 1/3 rule. And taking the curve, so now curve will be y1 x1 x0 x1 and x2. So this will be the curve. So this is y0 y1 and y2. So taking the curve to x0 y0. So this is x0 y0, then x1 y1. So x1 y1, this is y2, then and x2 y2. Okay. So taking the curve through x0 y1 as a parabola. So this is okay. So that is it is a polynomial. So it is a polynomial of second order. So this is polynomial of second order. So difference of higher order. So that difference of other higher order then second. Okay, so this is second difference. So the higher order difference will become 0. Okay, so this is there. So this is very big, and we get. So we are substituting n is equal to 2 here. Okay, so so this curve represent a parabola. So this is a polynomial of second order. So higher orders, which is greater than 2, second order will vanish, will be equal to 0. So we substitute 2 here. So this will be equal to. So this will be x0 plus 2h. Okay, n is equal to 2. So f of x is equal. So this will be 2h y0 plus 2 upon 2 delta y0 plus 2 into 2 minus 3 divided by 12 delta square 1. And higher order become 0. Higher order difference become 0. Okay. So this will be equal to 2h y0 delta y0. This is 4 minus 3. Del 2 upon 12 6 upon 6. Okay. So we will remain with this. Okay. So this is 2h y0. This can be written as y1 minus y0. This is del y1 minus del y0 divided by 6. Okay. So further we can simplify this and we can take formula in terms of y1 y2. Okay, y0. So this is x0 plus 2h f of x dx is equal to 2h. So this is y0 This is y1 minus y0, and this is del y1 is y2 minus y1 minus del y0 is y1 minus y0. So this will be y1 plus y0 whole divided by 6. Okay. So this is 2h. So y0 cancel out. Y1 plus this is y2 minus 2y1 plus y0 divided by 6. Okay. This is 2h 6y1 plus y2 minus 2y1 plus y0 divided by 6. So this will be h upon 3. So 6 minus 2 will be 4. So y2 plus 4y1 plus 1. Okay. So on deducing this, you will get this value. Okay. So similarly, for next curve, so this will be x naught, which is incremented by 2h. This will be x naught 2h f of x dx h upon 3. So this will be y2 so right here 0 and 2. So y2 plus 3y1 plus y3 and 1. Okay. Next y0 plus 4h x0 plus 6h f of x dx. So we will h upon 3. So we start with y4 plus 3 4 4y5 plus y6. Okay. So we will write its nth term. So nth term will be x naught plus n minus 2 into h, x naught plus n into h, f of x dx is equal to by 3. So this is yn minus 2 plus 4 times y n minus 1 plus y of n. Okay, so this is y of n. So what we can see here, so this is y0 and this is y of n. So all the odd terms y1, y3, y5 is multiplied by 4. Okay, and it is y2, so this there will be 2y2, y4, 2y4, and even terms are twice. Okay, so 2y2 plus 2y4 plus 2y6 and so on. So we can add all these integrals, adding all these integrals. Okay, so we have x naught plus n h f of x dx is equal to h upon 3. Okay, so y0 plus y of n. Okay, so they will be clubbed together, and these are odd terms. Okay, so plus 4y1 plus y2 plus y3 up to yn minus 1 plus twice y2, y4, y6 even terms. Okay, plus yn minus. Okay, so this is known as Simpson's 1/3 rule. So you have to remember all these formulas. Remember Simpson's 1/3 rule. Okay, or Simpson rules. Okay, so if it is given only Simpson. Okay, so this is second quadratic formula. Then similarly you can find the third quadratic formula. It is Simpson 3 by 8 formula. Okay. So this is Simpsons 1/3 formula. So next, fourth one is, so third one is Simpsons 3/8. Okay, so here you will put n is equal to 3. Okay, so we have started from n is equal to 1. So we have found the trapezoidal rule. Then n is equal to 2, we got the Simpson 1/3 or Simpson rule. And when we put n is equal to 3, we get Simpson 3/8 rule, which is where n is equal to 3 substituted in equation 1. Okay, so we derive all this equation using this Newton Cotes quadratic formula. Okay, so the graph, the curve will be like this. So this will have this is x0, x1, x2, and y0, y1, y2, and y3. Okay. So this is the polynomial of third order. Okay. So again, now as it is polynomial of third order, so we have only this difference of order 3 only, and higher than this third order, this will vanish. Okay, this will become 0. Okay, so the curve passes through x0, y0, x1, y1, x2, y2, and x3. Curve passes through x high and y high, where I is equal to 0, 1, 2, and 3. Okay, so this is polynomial of third order. Okay, so the difference above than third order will become 0. Okay, so putting n is equal to 3 here, so this will be x0 plus x0 plus 3h f of x dx is equal to 3h. So this is y0 plus 3 by 2 del y0 plus 3 into 2 into 3 minus 3 divided by 12 del square y0 plus 3 into 3 minus 2 whole square by 24 del 1. Higher order become 0. Okay, so on solving this, you will get 3h. So y0 plus 3 by 2 delta y0. Okay, so this is 6. So y0 by 4 plus this is 1 square. So this will be 3 upon 24, 1 upon 8 del cube 1. Okay, now substitute the values of forward difference del y0, del square y0, and del cube y0. So we are not going to derive all. We are directly writing is 3 upon h divided by 8 y0 plus 3 y1 plus 3y2 plus y3. Okay, so just substitute del y0 as y1 minus y0. Okay, and this will be del 1 minus del y0, and again solve this. So this is del square y1 minus del square y. Okay, on solving this, you will get this 3h upon 8 y0 plus 3y1 plus 3y0 plus y cube. Okay, so similarly, third, second, y0 plus 3h, y0 plus 6h, f of x dx. So why it is known as 3, 8? Because this is 3 upon 8. In previous formula, it is 1 upon 8. So this, therefore, it is known as 1 upon 8 Simpsons. Okay. So this is 3h upon 8 y3. So start with y3 plus 3 y4 plus 3 y5 and y6. Okay. So we can write it up to n terms. So to n terms. So adding all this, so x naught plus nh f of x dx is equal to 3h upon 8 y naught plus yn plus, so this is 3y1. Okay, so 3y1 y4 3y2 y5, and this is 3 this will be 2y2 plus 2y6. Okay, so this is 3y1 plus y2, there will be no y3, y4 plus y5, there will be no y6, and dash up to yn minus 1. Okay, plus 2 times y3 plus y6 plus y9 dash up to n minus 3. So this is Simpson's 1/8 rule. Okay, so here you can see this is y0 and this is yn. So 3 y1 y2 y4 y6. Then third term, next term will be equal to 8 y6 plus 3 y7 plus 3 y8 plus y9. Okay, so there will be 2y2, 2y6 and 2y9. Okay, so this is 2y3, y6, so multiple of 3, and then 3y1, y2, y3, y4, y7, y8. So third multiple of y will be absent here. Okay, so this is Simpson's 1/8 rule. Okay, so next, fourth one is Rule's method. Okay, so this is obtain putting n is equal to 4. Okay, so you will get a curve which has 4 points. So this is x0, x1, x2, x3 and x4. Okay, so we will find a under this curve. Okay, so this is y0, y1, y2, y3 and y4. So curve passing through the points y0, x1, so y0, y0, x0, y1, x0, y1, x0, y0, x1, y1, x2, y2, x3, y3 and x4, y. Okay, so again we will take the difference up to fourth difference. So this is a polynomial of fourth order. So only we have to take the difference of fourth order only, and above this will be equal to 0. Okay, so I am directly writing the formula. Okay, so you can derive it similarly. So putting n is equal to 4. Okay. So I am writing its formula. So x naught plus nh f of x dx, which is this method, is equal to 2h upon 45 7y naught plus 32y1 plus 12y2 plus 32y3 plus 14y4 plus 32y5 and last Weddle's method. Here it is. So here putting n is equal to 6 in equation 1. Okay. So this will give a polynomial of 6th order, and difference up to 6th order will be taken, and above this will be equal to 0. Okay. So neglecting all differences. So neglecting all difference above 6. Okay, so we obtain, and so I am writing that formula. So x naught nh f of x dx is equal to 3 upon 10 th upon 10 y naught plus 5 y1 plus y2 plus 6 y3 plus y4 plus 5 y5 plus 2 y6 plus 5 y7 y. So this is Weddle rule. So out of this 5 rule, this Weddle rule gives most approximate solution. Okay. So this rule, Weddle rule, generally give more accurate than any other rule. Okay. So now we will solve one numerical based on this. So we will. So this is Simpson's create rule. Okay. This is Rule's rule, and this is Weddle. Okay. And we have derived Simpson's 1/3 rule and Trapezoidal rule earlier. Okay. So you have to remember all these 5 rules. So in exam, any of 5 rules can be asked. Okay. So start with first numerical. This is very simple. You have to remember this formula only. Okay. So evaluate. So this is very important question that we ask in exam. So you have to integrate from 0 to 6 d of dx 1 upon x square. Okay, by using. So in calculator you generally solve this equation. Okay, so in calculator. So they generally use this rule to calculate. Okay, so programming of these rules are feed in the calculator and they solve this equation, integral equation. Okay. So by using first trapezoidal rule, then Simpsons 1/3 rule, then Simpsons 3/8 rule, and fourth is so you have to evaluate, you have to find the value of 1 upon 1 plus x squared dx, and the limits are given from 0 to 6 from trapezoidal rule, Simpson rule, Simpson's 1/3 rule, 3/8 rule, and Weddle rule. Okay, so you have to remember this formula. Okay, and here in this formula, this is Weddle's formula. Rule. So you have to find y0, y1, y2, y3, y4, y5, and y6. Similarly here y0, y1, y2, y3, y4. And in question, it is not given. The values of y is not given. Only a function 1 upon x square is given, and limit is given from 0 to 6. Okay. So how to solve this? So one question will ask, minimum one question will be asked from this numerical integration in the exam. Okay. So just remember this formula. Okay. So here there is no need to draw the prepare difference table. Okay. So so first we have to find y1, y2, y3. So divide the interval. Divide the interval into 6 parts. Okay, so we are dividing this interval from 0 to 6 into 6, and width of each part, that is x is equal to. Okay, so we are dividing this 0 to 6. Okay, this interval into 6 part, and value of h is 1. That is 0 to 1, 1 to 2, 2 to 3, and so on. Okay, so you have to do it by yourself to how to divide this integral. Okay, so f of x, let f of x 1 upon x. Okay, so we have to find the values of y1, y2, y3, y4, and y. So what will we do? We put the values of x. Okay, so we have divided 0 to 6. So this is x is equal to 0 to 6. So it will be 0, 1, 2, 3, 4, 5, and 6, and we will substitute here, and we will find correspondingly f of 0, 1, 2, 3, which is y1, y2, y0, y1, y1, y2, y3, and so on. Okay. So now we have to prepare table. Okay. So values of x is 0, 1, 2, 3, 4, 5, 6. Okay. So okay. So we have to find f of x is equal to 1 upon 1 plus x square, which is 1. Okay. So we will find corresponding values of, so this is x0, x1, x2, x3, x4, x5, and x6. Okay. So we will find corresponding value of y0, y1, y2, y3, y4, y5, and y6. Okay, so what we have done, we have divided this interval 0 to 6 into 6 part, 6 interval. Okay, and width of each part is 1. So 0, 1, 2, 3, 4, 5, and 6, and we will find the corresponding values of y. Okay, so this is our aim. So this is y0, y1, y2, y3, y4, y5, and y6. Okay. So we will find the corresponding values of y0. Okay. So what is y? It is 1 upon 1 plus when x is equal to 0 first. When x is equal to 0. Okay. So y naught will be equal to 1 upon 1 plus 0. So this will be 1. Okay. So y naught is 1. Next, when x is equal to 1, y1 1 upon 1 plus 1, so this will be 0.5. When similarly x is equal to 2, so y2 will be equal to 1 upon 1 plus 2 square 1 upon 5. This is 0.2. Then for x is equal to 3, when x is equal to 3, 1 plus 3 square. So this is 1 upon 10, 0.1. When x is equal to 4, so y4 is equal to 1 upon 1 plus 4 square, 1 upon 17, which is equal to 0.05. Then x is equal to 5, y5 is equal to 1 upon 5 square, 25, 1 upon 26 is equal to 0.0385. And last, x is equal to 6, y6 is equal to 1 upon 1 plus 6 square, 1 upon 36 is equal to 0.06. Okay, so you can find the values of y like this. Okay, so we have to take this is equal to f of x is equal to y is equal to 1 upon x and substitute the value of x is equal to 0, 1, 2, 3, 4, 5 and find the corresponding values of y0, y1, y2, y3, y4, y5, y6. Okay, and prepare this paper. Okay, so now we'll find the value of integration 1 upon x square dx by using different rules. Okay. So first, Trapezoidal. So integration from 0 to 6, 1 upon x square dx is equal to h upon 2 y0 plus yn, so yn is y6 plus 2 y1, y2, y3, y4 and y5. Okay, so this is trapezoidal rule. So what is h? H is 1, so divided by 2. Value of y0 is 1 plus y6 is 0.027 plus twice of y1 is 0.5 plus 0.2 plus 0.1 plus 0.0588 plus 0.038. Okay, so on solving this we get 1.140. Okay, so this is very simple method. Okay, so you have to remember only this formula. What is important here? You have to remember this formula, and it is quite easy. So when you are using trapezoidal rule, so this is h upon 2. Okay, write first term of y and last term of y. Here first term of y is y0 and last term of y is y6, and then twice of remaining terms of y, y1, y2, y3, y4 and y6, and substitute these values and you will get this formula. Okay, next by Simpson's rule or Simpson's 1/3. So 0 to 6, 1 upon x square dx equal to h upon. This is 1 upon 3. This is h upon 3. Again, first term and last term. So this is y0 plus y6 plus 4 times the odd terms y1 plus y3 and y5 plus twice of even terms y2 plus y3. Okay, so this is the formula. Okay, so you have to write. So this is Simpson's 1/3. So this will be h upon 3. Write first term and last term. First term is y0 and last term is y6. Then 4 times the odd values of y, that is y1, y3 and y5, plus twice even values of y. Okay, so this is h is 1 upon 3. So y0 is 1 plus y6 is 0.027 plus 4 times y1 is 0.5 plus y3 is 0.1 plus y5 is 0.0385 plus twice of y2 is 0.2 and y4 is 0.058. Solving this, so these are approximate values. Okay, so we are getting 1.366. Okay, so this is varying, it is 1.418. So using trapezoidal you are getting 1.4108, and by using Simpson's 1/3 you are getting 1.3662. Okay, then we will use Simpson's 3/8 rule. This is the first. So this will be, again, write the first term and last term. Okay, so 1 and this is 3 upon 8. So 3 upon 8 should be h upon 8, y0 plus y6, and 4 times, sorry, 3 times the y1, y2, y3 will be absent here, y4, y5. So multiple of 3 will be absent plus twice y3. Okay, so y6 is used here. So you have to write 3 y1, y2, y4, y5. Don't write multiple of 3. So this will be 3 and 6 is used here. Okay, so this is Simpson's 3/8 rule. Okay, so this is h is 1, so 3 upon 8, y0 is 1 plus y6 is 0.027 plus thrice of 0.5 plus 0.2. Don't use y3 plus 0.0588 plus 0.0385 plus toss of y3 is solve this, you get 1.35 seconds. Now last Weddle's rule. So this is very simple method. Only thing you have to remember the formula. Okay. So no need to draw this difference table. That's why support by Weddle. So 0 to 6 1 plus x square is equal to 3 upon h by 10 y naught plus 5 y1 plus y2 plus 6 y3 plus y4 plus 5 y5 plus 6 y6. Okay. So now substitute this. So 3h is 1, y naught is 1, 5 into y1 is 0.5 plus y2 is 0.2 plus y3 into 0.1 plus 4 into y4 is 0.0588 plus 5 into y5 0.0385 plus 6. Solving this is equal to 1.3735. Okay. So in this way, you can find the integration 0 to 6 dv by dx 1 plus x square. Okay. So what we have done here, so the question is given, so you have to evaluate integration 0 to 6 dv by dx 1 plus x square. So values of y is not given. Okay. So what we have taken, so we have divided this integral 0 to 6 into 6 parts. Okay. So you have to decide in how many parts you have to divide it. Okay. So here it is given from 0 to 6. So we have divided this into 6 parts. Okay. 6 equal parts. So here h will be equal to 1. So values of x will be from 0, 1, 2, 3, 4, 5, 6. Okay. So similarly, you can find the values of this y, which is 1 upon x square. Okay. So substitute the value of x 0, 1, 2, 3, 4, 5, 6, and you will get y naught, y1, y2, y3, y4, y5, and y6. Okay. And then use different rule like their formulas. Okay. And substitute the values of y1, y2, y3, y4, y5, y6, and so on. Okay. So you can do like this. You can take as 12 parts, so h will become 0.5. Okay. So you can take any parts, so but the calculation become more tedious. Okay. So this will become more cumbersome. So to avoid this, you have to take such intervals, so you can solve this easily. Okay. Although if you take more parts, the answer will be more accurate. Okay. So but to avoid this this tedious calculation, we go with this type of division of the parts. Okay. So at the end, you have to remember this formula. This method is very simple. Okay. Every time the formula will be given. We have to find x into e to the power x from 0 to 7. Okay, so it is clear from 0 to 7. So you have to take 7 parts. Okay, it is from 0 to 5. You have to take 5 parts. Okay, so so sometimes it is given like this from 0 to 1. Okay, so how many parts you will take? If you find, you have to find x e to the power x dx. So how many parts you will take? Value of h. It is integration is from 0 to 1. 5. Very good. Anyone else? You can take it as 4 also. Okay, 4 parts also. Okay, so if you take 4 parts, so h will be equal to 0.25, and if you take 5 parts integral, so h will become 0.2. Okay, so you can calculate accordingly. So 4 parts h will be 0.2 and 5 parts h will be equal to 0.2. So here calculation will take some more time as compared to 4 parts. Okay. So in this class we will solve some more problems based on this numerical differentiation. Okay. And here if you integrate, forgot to tell part. So if you integrate this dv by dx, sorry, this integration 0 to 6, if you use calculator, it is coming to, that is tan inverse x from 0 to 6 is coming to 1.405. So this is the actual value of integration dv by dx, dv by 1 plus x square is equal to 1.4056. So we are getting somewhere near the value. So this is 1.378, this is 1.35, and it is 1.418. Okay, so in trapezoidal we are getting more than the correct value. So if you take more parts, you will come more closer to the correct value, accurate value. Okay, so this is you can see the error. Okay, so this is the correct value of 0 to 6 dv by dx and dx by 1 plus x square. Okay. So in the next class, we will solve some more problem on based on this quadratic formula, Simpsons 1/3, 3/8, and Weddle's formula. Okay. Thank you, class.